Alright guys, last video for the week. There's no official assignment, but I do recommend that you follow along with today's video. There's going to be a lot of times where I ask you to pause, try a question, and then unpause to see if you have the right answer. So make sure you've got pencil and paper or something like that off to the side so that you can work through these, okay? Alright, so let's say we wanted to solve these basic radical equations. When we solve, we already know we need to do the inverse operation. So our example is x plus 2 equals 5. We would subtract 2 from both sides, right? And then get x equals 3. Same exact thing follows for radicals and roots and exponents and all that sort of thing. So to get rid of this squared, we square root both sides. So on the left, I get x, and on the right, I get 2. Okay, so let's look at letter B. And to do the opposite of square rooting something, I need to square both sides. So that turns into x equals 16. Okay, to do the opposite of cubing something, I need to do what's called cubed rooting, which basically means what number times itself 3 times gets me -8. So before, we can't do square root of a negative number, but we can in fact do cubed root of a negative number, knowing that the number itself has to be negative for that to happen. And if I use 2 times itself 3 times gets me -8. So the cubed root of -8 is in fact -2. Last one, the opposite of cubed rooting is cubing. So I get x equals, and then 8 to the 3rd power, I don't know that off the top of my head, but my calculator tells me off to the side that it's 512. Okay, so today what we're going to be talking about is how to solve equations that have radicals in them. All right, so let's do a couple examples together. So here's the first one. First thing I'm going to do is subtract 4 from both sides. So I get -1. The opposite of cubed rooting something is cubing. So what happens is it cancels that operation on the left side, and then -1 cubed is -1, right? So -1 cubed. That's where I got that from. Now I can solve it just like normal. Subtract 10 from both sides and divide by -3, so I get 11 over 3 positive, because negative divided by negative is a positive, okay? Let's go to the next one. Both sides have square roots, so I can just square both sides, and it actually takes the square root out of the picture for both. Subtract 8 from both sides, and then when I go to divide by 4, I get -5 over 4 is my final answer. All right, this next one, opposite of square rooting something is squaring it. So the left side, it disappears, and then a squared, I just write that as a squared. Now here's where you have to be careful. I don't know how to solve that, right? Like normally I would go, oh, square root both sides, but then we'll just get right back to where we started. So instead, because of this a squared, I think back to our prior knowledge and I go, oh, I can solve this like a quadratic. I can make this a squared, move the positive 10a and make it -10a, and move the -16 and make it +16, and now I can solve it just like a quadratic like we did in chapter 9. So easiest way to solve a quadratic is, answer that to yourself rhetorically, the correct answer should be factoring. If you are still saying quadratic formula, you're going to regret that when you get to Algebra 2. Trust me, factoring is the easiest way if it's possible. So I need two numbers that multiply to give me 16, but when I add them, I get -10. So I'm thinking -8 and -2. So then my solutions are +8 and +2. So notice how quadratics are kind of sneaking back into these last two chapters. All right, last example. I'm going to square both sides, so the left side just turns into k plus 1. But be careful, when I do k minus 1 squared, I have to put that in parentheses. That doesn't just turn into k squared plus 1. Remember, that's like double distributing. Okay, so you almost have to imagine that in your head and write it all out. So the right side turns into k squared minus 2k plus 1. And then I kind of do the same thing I did over here where I turn it into a quadratic. So I'm going to make this 0, subtract k over and make this -3k. And when I subtract 1, actually, I just get 0. So I say, okay, well, how am I supposed to factor that one? Well, this one, there's a GCF. I can take k out of both of those terms, and that's like a GCF, right? So one of my solutions is k equals 0, and the other one is k equals 3. Okay, one thing you have to be careful of, and you won't see this very often, but are things called extraneous solutions. Notice how the first word in that phrase is extra. What happens is, you guys, and I know it's kind of weird, but especially when we square both sides of the equations, sometimes we create an extra answer that doesn't actually make the equation work. So for example, for this one right here, if I plug 8 back in, I get negative 16 plus 10 times 8 is equal to 8. So that's negative 16 plus 80, which is square root of 64. And square root of 64 is 8, so we're good. So what if I plug in 2? Negative 16 plus 10 times 2 equals 2. And I get, so negative 16 plus 20, that's 4. So that one works and we're okay. But sometimes what happens is, because we have this squared, we need to check both of our answers if we do in fact get 2 answers, because there are going to be times where it doesn't work. So for example, on this last one, what if I plug in 0? I get this right here. So on the left side, I get square root of 1 is equal to negative 1. I mean, technically that's true, but it's not just equal to negative 1, right? It's equal to plus or minus negative 1, or like we've been practicing, just the positive version. So 0, what we would do to say it's extraneous is we check it, we say, wait a second, that doesn't work. We put an X through it, and then we just draw an arrow or something like that and write the word extraneous. So technically the only answer for this one is 3. All right, with your pencil and paper, let's go ahead and try some practice problems. And at the end of this video, once you're done practicing, you are done for this week, and I will see you guys again on Monday, okay? So we're gonna do whiteboard practice remote learning style. So you're gonna follow along, pause the video, try each problem, and then unpause it to see the answer. All right, pause the video at this time and try this question. When you're ready, unpause it. All right, first step. Add 2 to both sides, square both sides, and then add 3. All right, let's try another one. Try this one. Pause the video when you are ready. All right, answer to this one, we need to square both sides, right? So what happens is the right side, squaring the square root kind of cancels it all out. And on the left side, what you have to be careful of, it's like double distributing. So you have to make sure you write this as x squared minus 6x plus 9. Then I want to make it a quadratic and set it all equal to 0. And since this guy's positive already, I want to keep it positive. So let's subtract the x over and add the 1 over. And remember, easiest way to solve a quadratic, if it's possible, is to factor. So in this case, let's see if something works. Negative 2 and negative 5 would work. So my answers are 2 and 5. Now I have to check, because there's 2 answers, I have to make sure I didn't create an extra answer that doesn't work. So I'm going to switch my colors just so you know this is like extra. So 2 minus 3 is equal to square root of 2 minus 1. Okay, well that definitely doesn't work, so let's try 5. I get 2 over here and square root of 4, so that one's good. So x equals 5 is still good. I put an x through x equals 2, and I just write the word extraneous, okay? All that means is when I'm squaring both sides, I'm almost creating an extra answer that doesn't technically work with square roots, so you got to be careful. Let's try another one. Pause when, or unpause when you're ready to see the answer. All right, square both sides. So here's where you have to be careful on the right side, okay? When you go to square this, think about exponent properties. That means 2x times 2x. So make sure that you wrote 4x squared. My guess is you might have put 2x squared, or maybe you put 4x, right? So just be careful there. All right, to make it a quadratic, I'm going to keep that 4x squared and subtract over the 5x and add over the 3. And if it is possible, okay, I want to factor, so I'm going to use that ACB table, right? So 4 times 3 is 12. Are there 2 numbers that multiply to give me 12 but add to give me 5? 1 and 12, 2 and 6, 3 and 4. Well, not really. Well, shoot, okay, factoring didn't work. I guess I could complete the square, but with the 4 and the 5, I'm thinking completing the square is going to be way worse. So I'm going to go with the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2a. So I get 5 plus or minus 4 times 4 times 3 is 48. 25 minus 48 is negative 23. Well, remember, I can't take the square root of a negative number. So this means my solutions are imaginary. There are no solutions to this equation, and we would just stop right there. All right, we only got a couple more left, you guys. You can do it. Pause the video, give this a try, and unpause it when you want to see the answer. All right, for this one, here's where you have to be careful. What a lot of students will do is they'll start squaring right off the bat. You need to get rid of everything out of the way of the square root. So my first step is I need to subtract 7, divide by negative 2, and then I can square both sides, okay? So watch out for that. Make sure that you're not squaring everything too fast, and then it kind of screws you up a little bit, okay? Let's try another one. Unpause it when you're ready to see the answer. All right, if I'm squaring both sides, here's another one that's a little bit tricky. Like, I know the right side just turns into r plus 11, no big deal. But the left side, what you have to imagine is 2 root 3r times 2 root 3r. And then I have to use those operations we talked about earlier this week, where 2 times 2 is 4. Square root of 3r times square root of 3r. Well, a square root times a square root, doesn't that just cancel it, right? So it just turns into 3r. If you don't see that, you can write it as square root of 9r squared and then realize that that's the same thing as 3r. It's totally up to you. So that turns into 12r. All right, so subtract r from both sides, and we get r equals 1. All right, I believe we only have one more left. Last one. Give it a try. All right, so this one seems scary, but really once you get started, it's one of the more easy ones. We want to square both sides first because we want to get rid of that square root, right? Then we want to subtract 5 from both sides and then square both sides again. So even though it looked scary, that's the thing, you guys. Some of the ones that look scary are actually easier than the ones that don't look that scary, that turn into like quadratics, like that weird quadratic formula one we had to do a couple tries ago. So just be careful. All right, you guys, what's going to happen is on Monday, I'm going to give you a homework assignment that's all about this video. So once you're done going through the video today, you're good for the week. And I will chat with you guys again next week on Monday. So enjoy your weekend.